Okay, we're going to continue talking about arithmetic sequences here today. Yesterday we were using the recursive formula to find certain terms in a sequence, and today we are going to be using the one that majority of the time, if we can, we are going to be using, which is known as explicit formula. Okay, explicit formula. Now we will see some similarities between this one and the recursive formula. For instance, we do have still our desired term a sub n, what we're trying to find. We still have our common difference of d. All right, and as we said yesterday, we mentioned a sub 1 being the first term of a sequence. If we had to use a sub 2, that'd be the second term. A sub 3 would be the third term. We will notice that we now have an n by itself right here, or the n minus 1. N represents the number in the sequence. So before we had to use the first term to find the second to find the third to find the fourth, and keep going to the desired term. We now just need to take which term we're looking for and plug it directly into our explicit formula, which is going to save us a tremendous amount of time and effort. So to show this, let's go ahead and take a look at a problem that should look a little bit familiar, because this is the problem that we did yesterday. Okay, this is the problem we did yesterday, but today we're using the explicit formula. Okay, now first term of the sequence is 17 and repeats for each term in the sequence. Write the explicit formula and use it to determine the fourth term. So the exact same instructions. So first things first is I'm going to go ahead and write my explicit formula. A sub n, the desired term, is equal to a sub 1, the initial term, plus in parentheses n minus 1, n being the term that we're trying to find, and times the common difference, d. Okay? Now, two things here. One, in order to, yesterday when we were talking about the recursive formula, we had to get our equation by just plugging in the common difference d, okay? Because in order to know, we want this to be a kind of a stereotypical formula that we could use for any n that they gave us. So if we want the same thing here, we're going to have to figure out what a sub 1 and d is in order to figure that out. All right? Now I'm going to write them over here because we are going to use them here in a second for another reason. But in this formula here, the first term of the sequence is 17. We do know we have 17 there. And it repeats each time. That means we are adding 17 each time. So we start here, we add 17 to get the next, add 17 to get the next. And so 17 also is our common difference. Now, all we have to do is plug them in where we see them. So we will end up with a sub n is equal to our initial term, a sub 1, 17, plus, in parentheses, n minus 1 times the common difference, 17. Okay? Now tomorrow, in tomorrow's section, what we will do is we will learn about simplifying this a little bit, okay? Because we're going to be given a recursive formula that we're going to change to explicit, and we're actually going to simplify down even further if we want to. But for today, we're going to go ahead and keep using this, because if we were given this equation right here, there are three things we need to find: a sub 1, n, and d. So I usually put them in this order because I tell students to always find and. A sub 1, n, and d. It looks like it has and right there. Okay, we already found 17 to be not only in this one, the initial term a sub 1, but also the common difference, 17. We only need now what term we're looking for, since we're trying to find the fourth term. That's where the 4 comes from. Now we've already plugged in our a sub 1 and our d into this one, so if we just apply n into this equation, so the two locations that we have an n, plug in 4 for them. That means we're going to end up with a sub 4 is equal to 17 plus, in parentheses, 4 minus 1 times 17. Okay? Now, to simplify the math here, once again, if we do 4 minus 1, that's going to give us 3. 3 times 17 is going to give us a 51. And then combine those like terms, and we're going to end up with 68 right there. Okay? Which, as we see yesterday, if this is all the math that it really took, look at all the math it took us yesterday to get to 68. It definitely is a quicker process. Okay? Now, let's go ahead and continue this for the next three here. Okay? They want us to find the 12th term in all these sequences. Now, first things first, what I do recommend you always do, make sure you're dealing with arithmetic sequences. Okay? So you never know when one of them might not be that. So for instance here, to go from 1 to 8, 8 to 15, 15 to 22, we are doing the same thing each and every time, and that is adding 7. So that's going to be our common difference for this one. Let's go ahead and move to the next one real quick. If you want to try these last two on your own, you can pause the video. Okay? 2 to negative 6, we have to subtract 8. Negative 6 to negative 14, we have to subtract 8. But then we notice negative 14 to negative 23. Going from negative 14 to negative 3, we actually have to subtract 9. That's why we always want to make sure we have an arithmetic sequence for the sequence we're trying to write a formula for. Now I'm going to go ahead and quickly change that to negative 22 so that we can still do this problem, because if I change that to negative 22, the common difference is still the negative 8 like it was before. Now in this one over here, 22 to 28, we're going to add 6. 28 to 34, we'll also add 6. And 34 to 40, we will also add 6. So now that we changed that one little one right there, we now have 3 arithmetic sequences that we need to write, or need to use the explicit formula to calculate the 12th term. Now for all 3 of these, we're going to be finding and. Okay, a sub 1, n, and d, because once we have those values, all we have to do is plug them into our explicit formula. A sub n is equal to a sub 1 plus n minus 1 times the common difference d. Okay. So let's see what we have here. A sub 1 is the first term in the sequence, which is 1 here. N is going to be the same for all 3 of these because they're asking for us to find the 12th term, 12. And d is the common difference, which here it is 7. So once again, we plug in those values for everywhere that we see them in our formula. A sub n will now be a sub 12 equals a sub 1, our initial term, which will be 1, plus in parentheses, n minus 1, plugging in our n, that'll be 12 minus 1, times the common difference d, which will be 7. Okay? Which case, we go ahead and do the PEMDAS here. We do 12 minus 1 in parentheses, gives 11. 11 times 7 will give us 77. And then if we take 77 and add 1 to it, we will end up with 78. Okay? Once again, a lot quicker than if we would have had to have used the recursive formula. Okay? All right. If you want to try these next 2 on your own, go ahead and pause the video and try them. Otherwise, wait a moment. Okay? And these ones, we're going to do the same thing. We're going to find our a sub 1, n, and d, find our and, plug them in, and evaluate. So a sub 1, n, and d. Let's see what we end up with here. A sub 1 is the initial term of 2. N is the term that we're looking for, which we're looking for 12 in all of these. And d is the common difference, which ends up being the negative 8. Plug them now into our formula again. So we have a sub n, which is going to be a sub 12, equal to a sub 1, which here is 2, plus in parentheses, n minus 1, so that would be 12 minus 1 again, times the common difference of negative 8. Okay? I might do this one in 2 steps here because 12 minus 1 gives us 11, but then we have 11 times a negative 8, which will give us negative 88. So then we want to make sure we do that correctly. So 2 minus 88 does give us a negative 86 there. Okay. Go for one more here. Okay, so we're going to add 6. We already added 6 every time to find the common difference, but we need to make sure we find and all 3 values here. A sub 1, the first term in the sequence, is 22. N, once again, the term that we're looking for, that's been the same for all 3 of these, which is 12. And D, the common difference, is the 6. So let's go ahead and plug in what we know. A sub n, so n is going to be a sub 12 now, equals our initial term, 22, plus in parentheses, n minus 1 will now be 12 minus 1, times the common difference of 6. In which case, to do PEMDAS here, 12 minus 1 is 11. 11 times 6 is 66. And 66 plus 22 ends up giving us 88 there. Okay? Now, they don't even have to give us a sequence here. Okay? They could end up just giving us the bare minimum of information. If I were to make up an example for you real quick, once again, still using a sub n is equal to a sub 1 plus n minus 1 times the common difference of d. We've made up some values here. Let's say the first term of our sequence here is 102. Let's say we are going to be looking for the 47th term. And let's say the common difference going from one number to the next is we are going to be subtracting 16 every time. Even though the number is a little more complex, the process does not change. Plug in our values. A sub n, once again, a sub 47, is equal to a sub 1, our initial term, 102, plus in parentheses, n minus 1, 47, minus 1, times the common difference of negative 16. So, once again, if we just bust out our handy-dandy calculator here, we can just plug our value in directly into here. So 102 plus, in parentheses, we can go ahead and do 47 minus 1 probably, though, to give us the 46 there. And then times the negative 16. Okay? Just enter it in exactly like it was. We ended up with negative 634, which is going to be the 47th term in this sequence. Okay, a lot easier than going from a sub 1 to a sub 2, a sub 2 to a sub 3, finally a sub 46 to a sub 47. Okay? All right, that will complete the notes over this part. We will have one more topic over arithmetic sequences tomorrow. Make sure we're getting caught up on all of our lessons or our assignments. And as always, if you have any questions, send me an email.